Understanding the limit of a function, a simple guide. Hello, everyone. Today, we're diving into an essential concept in mathematics that often pops up when we're learning about calculus: the limit of a function. Whether you're just curious about math or tackling calculus head-on, understanding this concept is crucial. So, let's break it down into simple, easy-to-understand terms. Stay with us as we explore what limits are, why they matter, and how we can calculate them. In mathematics, the limit of a function is a fundamental concept that describes the behavior of that function as it approaches a certain point. Think of it as trying to find out the value that a function is getting closer to, as the input, or x value, gets closer to some number. For example, imagine we're walking towards a wall. As we take steps closer and closer to the wall, we're not exactly touching it but getting very close. The limit is like figuring out how close we can get to the wall without actually touching it. In mathematical terms, it's about understanding the value that our function approaches, as our input approaches a specific point. Limits are the backbone of calculus. They help us deal with situations where a function might not have a defined value at a certain point, yet we're interested in knowing the value it's getting closer to. This is especially useful when evaluating functions at points where they're not explicitly defined. Understanding the behavior of functions near certain points, which is essential in real-world applications like physics and engineering. Laying the groundwork for derivative and integral calculus, which are all about change and accumulation, respectively. Calculating the limit of a function might seem daunting, but it often follows a set of strategies that make it approachable. Here are a few methods. 1. Direct substitution. If the function is continuous, no breaks or holes, at the point you're interested in, you can simply plug in the value of x(x)(x) to find the limit. 2. Factoring. Sometimes, you can factor the function to cancel out problematic terms and then use direct substitution. 3. Special techniques. For more complex cases, there are special techniques, like L'Hopital's rule, which helps deal with indeterminate forms by using derivatives. Remember, the goal is to find out what value the function approaches, not necessarily the value at that exact point. And there we have it, a brief introduction to the limit of a function. We hope this video has shed some light on what limits are, why they're important in mathematics, especially in calculus, and how you can start calculating them. Remember, mastering limits is a step towards understanding the broader and fascinating world of calculus. Keep practicing, and don't hesitate to revisit this video if you need a refresher. Thank you for watching, and happy learning!